In the last video, we discussed how to evaluate double integral over a rectangular region. But in most of the cases, the region of integration will not be rectangular region, but some arbitrary region R. We shall see how to evaluate double integrals over the general regions. The general region can be of two types. Type 1, where the region R is bounded by the curves y equal to g1 of x and y equal to g2 of x and x equal to a, x equal to b. So it is as shown in the figure. So in the figure we can see that the region is bounded by the curves g1 of x, y equal to g1 of x, y equal to g2 of x and x equal to a, x equal to b. Similarly, we have type 2 region where the region R is bounded by the curves x equal to h1 of y and x equal to h2 of y and y equal to c, y equal to d. The region is as shown in the figure. So here the region of integration, which is the shaded region, is bounded between the curves x equal to h1 of y and x equal to h2 of y and y equal to c, y equal to d. Now let us see how to evaluate double integral over the general region. So let us consider type 1 where we are going to integrate f of x comma y over the region R with respect to a, where region R is the region bounded between the curves g1 of x and g2 of x and the lines x equal to a and x equal to b as shown in the figure. We draw a vertical strip. Along this vertical strip, y varies from g1 of x to g2 of x. And this vertical strip is moved horizontally from the point x equal to a and x equal to b, which covers the entire region R. And therefore, in this region R, y varies from g1 of x to g2 of x and x varies from a to b. And therefore, double integral over the region R of f of x comma y dA is equal to integral x equal to a to x equal to b, integral y equal to g1 of x to y equal to g2 of x of f of x comma y dy dx. So here we observe that the order of integration is first with respect to y and then with respect to x. Now the inner limit is the variable limit and it is for the variable y. So y varies from g1 of x to g2 of x and the outer limit is a constant limit, that is x equal to a to b. So to evaluate this double integral, first we integrate f of x comma y with respect to y between the limits g1 of x and g2 of x, which gives purely a function of x, and this function of x then integrated with respect to x between x equal to a to x equal to b, which is the result of the double integral. Now type 2, that is evaluation of double integral over the region R of f of x comma y dA, where R is the region bounded by the curves x equal to h1 of y and x equal to h2 of y, and y equal to c, y equal to d as shown in the figure. So here we consider a horizontal strip. So along the horizontal strip, x varies from h1 of y to h2 of y. This horizontal strip is moved vertically from downwards to upwards, that is from point y equal to c to y equal to d, which covers the entire region R. And hence in the region R, x varies from h1 of y to h2 of y, and y varies from y equal to c, y equal to d. Therefore, double integral over the region R of f of x comma y dA is equal to integral y equal to c to integral y equal to d, integral x equal to h1 of y to x equal to h2 of y of f of x comma y dx dy. So here the order of integration is: first, integrate with respect to x, treating y as constant between the limits h1 of y and h2 of y, and the resulted function of y is then integrated with respect to y between the limits y equal to c and y equal to d. So this is how we evaluate double integral over the general region. Now let us see some of the important properties of double integrals. So double integral over the region R of k into f of x comma y dA is equal to k into double integral over the region R of f of x comma y dA, where k is a constant. So when k is a constant, you can always pull out of the double integral and then evaluate the double integral. Now the second important property is double integral over the region R of f of x comma y plus or minus g of x comma y dA is equal to double integral over the region R of f of x comma y dA plus or minus double integral over the region R of g of x comma y dA. Suppose if the region R is made up of two closed regions R1 and R2, then that is, if R is the union of R1 and R2, then double integral over the region R of f of x comma y dA is equal to double integral over the region R1 of f of x comma y dA plus or minus double integral over the region R2 of f of x comma y dA. So these are three important properties of double integrals.